Assalamualaikum and hi! You are now watching a video presentation on plastic pollution, a material problem. Before we start, let me introduce myself. I am Hanani and I'm from Group 1. Display here on the slide the names of my group members. These are the contents of our presentation. So first, let's see the topic and focus of this presentation. As I mentioned the title of the presentation in the beginning of this video, you should already know that this presentation is basically about plastic pollution. And yes, we will discuss the issue of plastic pollution and its possible solution. So, our focus to raise awareness about the plastic pollution problem and to propose possible solutions to mitigate its impact on the environment, wildlife, and human health. Now we look at the problem statement. It has been identified that there is an increasing imbalance between the use of polymers and efficient end-of-life options. It refers to the growing disparity between the production and consumption of polymers, particularly plastic, and the capacity to effectively dispose and recycle them at the end of their life cycle. Plastic pollution is not solely a material problem, as it has a significant impact on the environment, wildlife, and human health. Some of the impacts that can be mentioned are carbon emission, transfer of toxins, food and water contamination, etc. Carbon emission. The life cycle of plastics, including their production, use, and disposal, can contribute to carbon emissions. The production of plastic materials such as polyethylene and polypropylene typically involves the extraction and refinement of fossil fuels. These processes emit greenhouse gases, including carbon dioxide, methane, and nitrous oxide. Next, transfer of toxins. It can occur through the food chain of bioaccumulation. Animals that consume plastic, especially marine life, may also ingest toxic chemicals that are absorbed by the plastic. These toxins can accumulate in their bodies and transfer up the food chain, potentially affecting human health as well. Last but not least, food and water contamination. Plastic pollution can contaminate agricultural lands and water sources such as rivers, lakes, and oceans, then potentially affecting the safety and quality of food supplies and drinking water. In short, plastic pollution is a crucial issue that must be solved. So, I'd like Habib to continue with the next part of this presentation.
I would like to present the review of solutions. The solutions for plastic waste is reduce, reuse, and recycle. The reuse of plastic products is the shortest and most favorable solutions. And there are 4 recycling strategies. The first one is mechanical, the second one is biochemical, the third one is organic, and the fourth one is environmental. So, the first recycling strategies that we have is mechanical recycling. Because of mechanical recycling, thermoplastic can be softened or melted on heating and can be reshaped. And then, mechanical recycling also developed a new and simple methods of sorting plastics. For your information, the presence of more than one polymer type together with layers of non-polymetric materials make mechanical recycling of such packaging difficult. Therefore, efficient separation procedures have been researched to separate different plastic types from a multi-layer packaging film with almost 100 material recovery efficiency, which can be used again in the manufacturing process. For example, special adhesives are being developed based on reversible cross-linking and the cross-linking chemistry occurring at different temperatures to provide easy delamination of the plastic layers after use, simply by heating at a particular temperature before they can be mechanically recycled. The second recycling strategies that we have is biochemical recycling. Biochemical recyclings are developing techniques for chemical and biological recyclings of existing commodity and specialty polymers, in which a polymer is either converted to its original feedstocks, monomers, or recovered as a purified polymer. The new products resulting from chemical recycling can be used to prepare new or original polymers or be used for other purposes with a closed-loop circular economy approach. Next, biochemical recycling also have a design principle that has been developed to introduce chemical recyclability by creating chemically cleavable bonds in the polymer backbone of thermosets. So, the progress made for the recyclability of thermoset is commendable. It provides a chance to recover reinforcing expensive fibers used in fiber-reinforced thermoset, composites, and not only the matrix polymer. So in general, biochemical recycling technology offers several different opportunities for recovering feedstocks, monomers or polymers, and shows promise as one of the end-of-life paths for plastic waste. So the third recycling strategy is organic recycling. Organic recycling use specially designed biodegradable polymers that can undergo mineralizations by microorganisms under composting conditions in the same time frame as other organic waste in the compost. In this context, composting results in a complete breakdown of a compound to biomass and either fully oxidized or reduced simple molecules such as carbon dioxide, methane, nitrate, ammonium, and water, which can be further utilized as a biofeedstock, which is organic recycling. Current research in the development of compostable synthetic biodegradable polymers primarily focus on aliphatic and aliphatic aromatic polyesters. So what is aliphatic and aliphatic aromatic polyesters? These polymers are prepared by ring opening polymerizations and condensation polymerizations. For example, polybutylene adipate 3 phthalates (PB80) synthesized by condensation of 1,4-butanediol with terephthalic acids and adipic acid, and it is a commercially available polyester that shows 75% biodegradation in industrial compost in 8 weeks that increased to more than 19% in 12 weeks. Like PB80, the ester functional group in several other aliphatic and aliphatic aromatic polyester has the capability of undergoing biodegradation under industrial composting conditions.
For the fourth type of recycling, we have environmental recycling, which involves polymers that decompose in natural soil environment, or in other words, soil biodegradable, and the product biodegradation can be used as biofuels. The polymers used in environmental recycling may be produced with organic recycling units, as they both use the same kind of polymers, which are biodegradable polymers. The key difference between them is that environmental recycling polymers are naturally biodegradable, while organic ones have to be designed to be biodegradable. And there are three conditions that have to be met by a polymer in order to be considered environmental recycling. And they are polymers that biodegrade in agricultural soil in an accepted time frame, meaning that it has to decompose in a short time. Secondly, without changing the location, meaning that they can't change their medium plant once planted. And lastly, they can't bring toxicological effects to the soil for the entire life cycle, meaning that they have to decompose completely without harming the environment. An example of environmental recycling polymer is aliphatic and aliphatic aromatic polyesters. The only problem is that they have a low biodegradation rate of 150 days, which is very slow considering that they would cause polymer fragments to remain in the environment for several years, or completely mineralizing into biomass, carbon dioxide, and more. However, there are benefits to environmental recycling polymers, which are enhancing soil health and also aid in minimizing environmental impacts and particle accumulation in various habitats. Right here, we have a graph showing the effects of different mulch treatments on the soil's nitrogen content, with the white bar representing a plant with no mulch, the gray bar in the middle representing biodegradable films, while the black bar representing a plant with polyethylene pheromones. Now, pheromones is a type of environmental recycling polymer included in the Fertilizers Regulation of Europe as a soil utility. And the graph shows that the gray bar, or the plant with biodegradable pheromones, has the highest amount of nitrogen content. And nitrogen is a very important element for a plant as it contributes a lot to the growth. Thus, this proves that the environmental recycling gives nutrients to soil.
Next, we are moving to recommendation and justification based on the possible solution that we choose. So, based on the review of solution discussed earlier, we come to an agreement that biochemical recycling is the best possible solution. For recommendation, it is an effective method for reducing plastic pollution by breaking down plastic into their basic building blocks, which can be the plastic original monomer or polymer for reuse in various industries. These technologies can break down plastic and transform them into valuable secondary raw materials to produce new chemicals and plastic with the same quality as those made from fossil resources. For justifications, we want to justify that majority of plastic waste in the US ends up in landfills where it generally does not biodegrade or break down over time. A relatively small portion of plastic waste is incinerated and an even smaller portion recycled. In order to address the problem caused by plastic pollution, biochemical recycling, which is an advanced form of recycling technology, offers an alternative option. It involves breaking down waste plastic into its specific molecules, which can be used afterwards as a source to create new plastics, chemicals, or other useful good. So, how does it work? So, chemical recycling technologies use heat, chemical reaction, or maybe both to break down used plastics into raw materials in which a polymer is either converted to its original feedstock, monomers, or recovered as a purified polymer. The new product resulting from chemical recycling can be used to prepare new or original polymer or even be used for other purposes such as plastic and fuel. So, why do we recommend biochemical recycling as an approach? Firstly, it targets a closed-loop circular economy. The chemical industry helps increase resource efficiency together with utility and enables a more circular economy for plastic. All the worthless plastic waste would become economically beneficial to recycle, all thanks to the ways of chemical recycling can turn it into valuable secondary raw material. By breaking down plastic waste into its basic building block, such as monomers or polymers, these materials can be used as feedstock to produce new plastics, reducing the reliance of fossil fuels and virgin plastic. This approach helps to create a closed-loop system where plastic waste is continually recycled, reducing the need for raw material extraction and the associated environmental impact. Next, chemical recycling helps to reduce landfill and the leakage of plastics into the environment. Chemical recycling is an important means to fight the leakage of plastic waste into the environment, especially the littering of our oceans. It also contributes in lowering the carbon footprint of plastic production and end-of-life procedures such as landfilling and incineration. Reduced greenhouse gas emissions can be achieved by replacing fossil fuels-based raw material with raw material made from plastic waste after biochemical recycling. And last but not least, resource efficiency enhancements. Biochemical recycling maximizes the value and utility of plastic waste by converting it into valuable resources. The recovered materials can be used in a variety of sectors, including the production of plastic, chemical, and even energy generation. This method prevents shortage of resource, especially raw material, for plastic production and encourage the more sustainable use of resources, at the same time adopting an eco-friendly alternative.
In conclusion, plastic pollution is a serious matter that should not be taken lightly, and recycling can be a way to overcome it. Although there are many types of recycling, all of them are not equally effective, and we have found that biochemical recycling is the best method to recycle. Therefore, we call for everyone to practice the most effective way of recycling with hope that the environment can be saved from plastic pollution. That will be all from us. Thank you for listening.